I'm just finishing up for the evening. I reckon I'm going to go indoors and hit the sack now, but sort of do a little bit of information for young engineers who are making components that got to be welded together by welders or anything of that nature. It's a little bit different than what I'm doing here, but it's just the stuff I've learned over the years. If you're getting laser cut parts, which generally look like this, they always have oxidization on the side, which you guys will know if you deal with this stuff all the time. Now, this is an engine mount. This is what I've been working on for the evening, and all of these I've linished and prepped. So there's a small amount of prep on there, which is probably not enough for the weld we're going to do, but it's more acknowledging if these get MIG welded, I want to tick them up, but if they need to be MIG welded in the end, there'll be enough penetration that I'm happy that, there's 2 mil of prep there, so it'll be fine. The point I was just wanting to make for young engineers tonight is more every hole I cleaned up, I chamfered, even these ones that I've tapped through. The only ones that I haven't done yet, and I will still do, that have got slag or oxidization on them from the laser, are inside of here, which can flake off, and this is going to be internally in my tank, so I do not want bits of grit dropping off. When you get laser cut parts, you tend to go, oh yeah, that's great. The assemblies we make at work, at my work, we sandblast them at the end, and then they get powder coated. It's an essential part of making powder coat stick. My concern generally with the stuff I design is that we laser cut various parts like this and then weld them together. There's porosity going to happen. I've hand finished these, so they're fine. But if I was to weld this to this, you've already introduced oxidization and thereby porosity. If this was to be welded, because MIG only sits on the top really, there's very little burning of it. If you were actually trying to TIG weld this, it would probably bubble up as you actually TIGged it, because the slag and scale that comes off a laser cut part, it's going to get into the weld and affect your strength at the end of the day. So it was just something that occurred to me while I sat here, because I linish these, and I take the sharp edges off of the hand files still. No one's going to have the time to do that on a commercial level, but a lot of the young engineers I work with, we don't have time to clean anything up like this, and we blaze stuff up and put a lot of heat into it and weld these things. I just thought I'd show a bit of what I actually want for my own stuff. Now, here's another wee one that most of you may or may not know, but I've tapped these, so when you go to run it down, a bolt's never going to bottom. All of these are different. You need to countersink the back side of your hole, which is what I will do when I finish this up, to make sure that this amount of the bolt, where there is no thread, either needs a washer of a certain, not just a flat washer you buy down at Bunnings, it needs to suit the fastener, or you have to countersink it to suit. I'll be using these stainless bolts, button head screws I should say. This almost buttons up, but it still needs some relief because the thread, these are a quality fastener. So I'll get it out and show you what you probably all dealt with these anyway, everyone knows what nuts and bolts are, but that area right there where the last thread ends always needs a flat washer. You should never use a fastener without a flat washer. And if it was up to me, you would never use spring washers. Always use nylock nuts. So if you put a spring washer each side, a nylon nut, and if you can't fit a nylon nut because it's a little bit long for your bolt, just chuck Loctite on it, or anything you can do to lock it up. A spring washer is just something waiting to fail. I still use them on some of the bits on my car. You just can't get away from it, but if you approach it from that is the worst case scenario that you can do, spring washer, put it on. But if you've got the other option to use some good shit and use some Loctite, do it. But anyway, I was more talking about oxidization and porosity in the welds, because this is what I'm looking at here. I want these to not fail. I've just tacked these up with my MIG, but I've taken all that scale off from underneath here. So when these boys take these up for me, which I don't have argon at my house, I only got MIG gas, so we'll get these done at work if I can. And they don't want to be zipping along here. It's bad enough trying to get this MIG weld sorted. When you hit that with the TIG, it sucks in all sorts of crap off, that sucks all that in. So yeah, you don't want to be getting halfway down your weld and then pulling a big bubble in. So yeah, just bringing that up, because if you don't weld, or you don't come from a trade background like me, sometimes you don't know that, because the welder won't tell you. You'll just think your stuff that you're designing is shit. So yeah, just be aware of porosity, and don't think laser cut parts are the be all and end all, because look at this, there's even a dag on the end of here, a sharp bit where the laser line is finished. That's not going to sit square on here. You know what I mean? It needs hitting with the grinder or the file. So always put a radius on your laser cut parts if you can, because then that will sit there nicely, or a chamfer, whatever you got to do. But these sharp edges that I've done on this part are actually a great example of how not to do it, because someone's got to finish this now. So you've paid $2 for a laser cut part and it doesn't even fit. But I'm learning as I'm going, as we all do. But yeah, a lot of young blokes will. For instance, this is what I got out of the laser. I've finished this with a file, both sides, just to level it up, and it's still not even level, but it's not my finished part yet. I basically surfaced it with a file to try and make it as flat as I could, then tapped it, buffed it, but you can see the finish difference, where this has still got the mill finish on it. Black oxidization from the laser. With this, I've barely run it around the the lynching belt, and inside I mainly needed to get rid of the seam, which was where the laser starts and finishes, which is this bit here, because I don't want to catch the filter on it as I poke it into the tank, and I don't want a sharp edge there. So anyway, I'm probably harping on way too long over something I just thought would be a simple quick vid. Anyway, young engineers, be aware you need to hand finish your parts. Have a nice Sunday. See ya.